Hello, in our previous video tutorial we saw about how the Python language was implemented, how the Python virtual machine stored the bytecode in the PyCache and all the other representations in the internal files and all such details. Today we are going to see about how the code that you write in JavaScript turns into executable machine code that either runs on your browser or in Node.js in the backend. I chose JavaScript because it's an interpreted language, and in particular we are going to focus on the V8 engine that powers both Node.js and of course Google Chrome or any other sort of Chromium based browser engine. What we are going to do is create a simple JavaScript function, and then we will see how that is executed throughout the V8 engine. So let's get started. I'm going to create a function return 5, and I'm just going to return 5. I'm going to log the value to the output console, and that's it. Now let me open my terminal and check out whether it works fine. Example.js5. Yeah, fine. So what you see here, I am running it in Node.js rather than in a browser, but the same applies in the browser, and the reason I am running it in Node.js here is that we are going to have a look at some of the bytecode that is generated, and so it's going to be a little bit easier to do that with Node.js. The V8 engine needs to pass that source code, so there's going to be a little passing routine, and then what that's going to output is a thing called an abstract syntax tree. So we are not going to focus that now. So once that abstract syntax tree is created, that is going to be fed into an interpreter, and what the interpreter is going to do is take all that abstract syntax tree that's been produced, and then it's going to essentially turn it into a set of virtual bytecode. Right, so it's a sort of virtualized machine code. So think of it like a kind of a virtual machine, and then in particular the V8 engine is called Ignition. That V8 engine is what I'm going to focus on today. But once this is created, it's got this sort of a virtual bytecode that is abstracted away from any particular machine implementation, and then it may run through a couple of optimizers, and that machine code will get optimized a little bit, so things like caching or any other sort of speed ups that I think can be eventually done parallelly through some optimization modules also. So the interpreter has got this sort of machine abstracted code which will eventually get turned into something specific for a machine, and by understanding the virtual code and understanding this register machine, then I think that's going to help us become better JavaScript developers, because we will understand what's going on under the hood. So if you want to, you can really actually look in at the bytecode that's produced by the V8 engine, and how we would do that is we can type in node as we do normally, and then we would add in the flag dash dash print dash bytecode, and then we would just enter the name of our file, so in this case example.js that we created, and we will just run. And then what you see here is it's created a lot of unpleasant data there, and it's really hard to read, but actually there is a kind of filtering option that we have. So if I add in another filter, so dash dash print dash dash code, but this time I add filter, and then I set the filter equal to the name of my function. So I will call this return 5, and then we will get to run again, what's going to happen is it's only going to return the specific bytecode for the function that we have specified. So what we see over here is the name of the function return 5, and I'll come to this parameter count and register count and all these values a little later. So the bytecode is over here, and the instruction you see over here is LDA SMI5. So I can take a small guess here. This LDA stands for load accumulator with a small integer with a value 5, right? And the return is, of course, a bytecode instruction. And again, I'm going to run and modify my file. So let me so I'm going to key in my value here, and I'm going to change the value to 7 and going to return it and execute it from my node and the same function. And now you see that LDA SMI7 load accumulator with the small integer 7, and you see the value on the left here is modified to 7. And now let me change the value to 10, and what you see again, so you see here the value 10, load a small value 10, and what you see the value here is an A, 0A. So A is the hexadecimal equivalent of 10, and so this is how the bytecode looks. What we are going to do is we are going to return the value of x, and we are going to do a little bit of addition over here. We are just going to add the number 5 to that. So I am not going to put 5 into a constant. Now I'm just going to return the number 5. Run the Node.js, and we got 15. And if you want to look into the bytecode, we need to change the filter. It's going to be add 5 because that's my function. So we see here that it's called add 5. If you look at this, we see the register count is now 1. Remember, before we had 0 registers. Now we've got a register count of 1. We see this load into the accumulator LDA SMI 10, which is load to accumulator, and 0A, which represents the number 10 in hexadecimal. So we guessed that correctly, and so it's loading into the accumulator, and then we see this thing that's C3. So we've got a new opcode which is C3, and it says store A to R0. That's store accumulator value to R0s. We've now got introduced the concept of registers. So R0, we could probably take a guess that it's standing for register 0. So putting it all together, it's going to store whatever is there in the accumulator into register 0. So I took 10, I loaded that into the accumulator, so 10 is in the accumulator, and then I'm going to store whatever is there in the accumulator, and we are going to put it into register 0. And the next command is add SMI5. So what happens, add SMI means we'll essentially add whatever is there, that is the mathematical operation we do with the accumulator. So it's a bit of a clue that we are going to add the small integer 5 to whatever is already there in the accumulator. So it's going to take that take this number 5 and put it on to the accumulator. Now the accumulator was 10 before, now it's going to add that on to this, and then it's going to be 15, and then it will return that. So that's how all works. So now we'll create a new file, we'll call it accumulator, and we'll just simulate what's going on there in the accumulator. Rather me writing the exact JavaScript code that what we did before, what we are going to do is kind of write in JavaScript the kind of what's going on behind the scenes. So in this case we would have a variable called an accumulator. So the code is a bit of a weird structure, but that's what essentially what's going on. And we'll just run node accumulator, and as you see it's behaving exactly the same way as the underlying bytecode. Now that we understand what an accumulator is and what are the typical tasks it is used for, the way the code behaves, there are many more things that can be explored, like the working of a register and many much more things. We can catch up with it a bit later. Thanks for watching.